Have you ever looked up on a clear afternoon and just wondered, why is the sky blue? Not green, not purple, not colorless like the vacuum of space beyond it. Blue. It's one of those questions almost every kid asks, and honestly, most adults can't answer it either. So today we're going to fix that once and for all. Let's start with something you already know. Sunlight looks white, but that white light is actually a mix of every color you can see. Red, orange, yellow, green, blue, indigo, violet, all traveling together in a single beam. You can prove this to yourself with a simple prism or just by looking at a rainbow after it rains. That rainbow is sunlight being split apart into its hidden colors. Now here's the key idea. Light doesn't just travel in a straight line forever. It travels in waves, and different colors have different wavelengths. Red light has a long, lazy wave. Blue and violet light have short, tight, energetic waves. That difference in wavelength is going to explain everything. When sunlight enters our atmosphere, it runs into countless tiny gas molecules, mostly nitrogen and oxygen. These molecules are incredibly small, much smaller than the wavelength of visible light. And when light hits particles that small, something interesting happens. The light doesn't just pass through untouched. Instead, it scatters. It bounces off in random directions. Scientists call this Rayleigh scattering, named after the physicist Lord Rayleigh, who worked out the math in the 1870s. Here's the crucial part. Rayleigh scattering doesn't affect all colors equally. Shorter wavelengths like blue and violet scatter far more easily than longer wavelengths like red and orange. In fact, blue light scatters about 5 times more than red light does. So as sunlight streams into the atmosphere, the blue light gets grabbed by air molecules and flung in every direction, again and again, bouncing all across the sky. Meanwhile, red and orange light mostly continues on its original path, barely scattered at all. So when you look up, you're not looking directly at the sun. You're seeing scattered light, light that has bounced around the atmosphere and is now reaching your eyes from every direction. And because blue light scatters so much more than any other color, the whole sky appears to glow blue. Now, you might be thinking, wait a second. Violet light has an even shorter wavelength than blue. Shouldn't the sky be violet instead? That's a great question, and it comes down to 2 reasons. First, sunlight actually contains less violet light to begin with. Second, and just as important, our eyes are simply more sensitive to blue than to violet. We have 3 types of color receptors in our eyes, called cones, and the combination of how they respond makes our brains perceive that mixed scattered light as blue rather than violet. So it's not that violet disappears, it's that we're just not built to see it as clearly. This same idea explains sunsets too. When the sun is low on the horizon, its light has to travel through a much thicker slice of atmosphere to reach your eyes. Along that longer path, almost all the blue light gets scattered away before it ever reaches you. What's left is the red, orange, and yellow light, the colors that scatter the least. That's why sunsets and sunrises glow in those warm, fiery colors, while the middle of the day looks blue. And if you want proof that this whole explanation depends on having an atmosphere at all, just look at the moon. The moon has essentially no atmosphere, no gas molecules to scatter sunlight, so astronauts standing on the lunar surface see a jet-black sky in the middle of the day, with the sun blazing right next to pitch darkness and stars. No atmosphere means no scattering, and no scattering means no blue sky. So next time someone asks you why the sky is blue, you'll know the real answer. It's not a reflection of the ocean, and it's not some kind of paint in the atmosphere. It's simply physics. Sunlight made of many colors, tiny air molecules scattering short blue wavelengths far more than any other color, and our eyes picking up on that scattered blue light from every direction. It's a small daily reminder that even the most familiar things around us are full of fascinating science if you just take a moment to ask why. If you enjoyed learning about this, let me know in the comments what other everyday mystery you want explained next. And if you found this helpful, consider subscribing for more videos just like this one. Thanks for watching, and I'll see you in the next one.